Welcome to you all. So this lecture I would like to explain about coefficient of contingency. Coefficient of contingency. When the data represent in manifold classification we have to use coefficient of contingency concept to know the association between the attributes, association between the attributes. So now attributes. So whenever manifold classification, that means each variable classified basing on more than one criteria. Suppose to be you may be arrange this one in 2 by 2, suppose in 2 by 2 contingency table, or k by h contingency table, or m by n contingency table. In such a cases, to know the association between the attributes, we use coefficient of contingency concept. Here the first one is chi-square coefficient of contingency. Right? So it is denoted by chi-square. Read as this is chi-square, right? So defined as summation O minus E. O means observed frequency or the theoretical frequency, minus E means expected frequency, square by E. So that is nothing but chi-square coefficient of contingency. So let me tell about, suppose this is 2 by 2 contingency table, that means A, B, C, D, right? So this is the attribute A, this is the attribute B, right? So total is nothing but A plus B, this total is nothing but C plus D, and this column total is nothing but A plus C, this column total is nothing but B plus D. So this is nothing but then either the row total or the column total is nothing but N, that is the total frequency. In such a case, 2 by 2 contingency table, the chi-square value is calculated as N into AD minus BC by A plus B into C plus D into A plus C into B plus D. So here one more condition is there. No self frequency is less than 5. If any self frequency is less than 5, then you have to use Yates correction, right? So in 2 by 2 contingency table, you are obtaining the chi-square value by using this formula. Otherwise, you have to use O minus E whole square by E. So here expected frequency E is calculated as suppose this is nothing but AIBJ, right? So AI, next B, E is nothing but A B by N, Bj by N, right? So like you have to calculate expected frequency. Whenever you calculate the expected frequency, then you are O minus E, then square, then B, you are getting this. The next one is mean square contingency. Mean square contingency. Mean square contingency, right? So mean square contingency is nothing but we have to denote this is phi square equals to chi-square by N. Phi square, PHISQUARE. This is phi square. It is defined as chi-square by N. Chi-square by N. So the next one is third one, Karl Pearson's coefficient of contingency. Right? So in many of the cases, the chi-square and phi square limits are not coincide. That's why Karl Pearson proposed another coefficient of contingency that is called Karl Pearson's coefficient of contingency. It is denoted by C. That is square root of chi-square by chi-square plus N, right? Or else you can write, so divide numerator and denominator by N. You are getting chi-square by N is nothing but phi square. This is chi-square by N. So this is nothing but phi square plus 1 or 1 plus phi square, right? So this is nothing but Karl Pearson's coefficient of contingency. So this is also not approach to the unity, or you have to know here the Karl Pearson's coefficient of contingency value is less than unity. So that's why Tchprow, Tchprow proposed another coefficient of contingency that is called Tchprow's coefficient of contingency. This is denoted as T. So the square root of C square by 1 minus C square into K minus 1 into H minus 1. So what is the C? C is nothing but Karl Pearson's coefficient of contingency. Right? So what do you mean by K? K is number of subdivisions of attribute A attribute A. Similarly, H is nothing but number of subdivisions of attribute B, right? So, or simply the number of rows, number of columns. Suppose A is represented as the rows. This is nothing but the number of rows. Attribute B represented as columns. This is nothing but the number of columns. Or else you can write another formula is also basing on that one, chi square, that equals to chi square by n into square root of k minus 1 into h minus 1. Or else you can use another formula also. Another formula you have to substitute, that is nothing but square root of chi square by n is nothing but the pi square by square root of k minus 1 into h minus 1. So these are called Tchprow's coefficient of contingency. Right? So I summarize this video. So whenever you are having manifold classification of the attributes, now you want to know the association between the attributes or not, then you are using the coefficient of contingency concept. In this, so you have chi square contingency, mean square contingency, that is nothing but the phi square. It is defined as chi square by n. The next, Karl Pearson's coefficient of contingency. It is denoted by C. The square root of chi square by chi square plus n, or the square root of pi square by 1 plus pi square. The another one is, there is some demerits are there in coefficient in Karl Pearson's coefficient of contingency also. That's why Tchprow's developed another coefficient of contingency. It is based on Karl Pearson's coefficient of contingency, but the formula is square root of c square by 1 minus c square into k minus 1 into h minus 1. Right? So or else you can use chi square by n into square root of k minus 1 into h minus 1, or else you can use square root of phi square by square root of k minus 1 into h minus 1, where k represents the number of divisions of attribute A, h represents the number of divisions of the attribute B. So thank you for watching this video.